Hello and welcome to the HBM Frequently Asked Questions video series. This is the T12 Assistant 101. My name is Jason Osborne. I'm an application engineer out of Detroit, Michigan. Today we're going to be going over the T12 Assistant in detail. Wanted to go over some of the initial steps and how to set up your T12 torque transducer. Today I have a T12 1000 Newton meter torque transducer. I'm also using a CAN ABM12 terminating resistor, along with the T12 setup USB. This is the setup software that you can also be downloaded off of our website. This is the USB and CAN adapter. Like I mentioned, this could be used right off the CD or it can be downloaded on our hbm.com. It can be easily found under torque transducers and then go under T12. There's a whole section for software that you can download. So when you download this software and this first screen pops up, there's a couple different things you can do here. There's an offline version where you can go through and learn all the hardware offline that's not connected to the T12, or you can connect right to the T12 using CAN. So when you first scan, hit the scan button, the address of the torque transducer is going to come up and the type and the version. If you have multiple torque transducers in a series, you can be able to scroll right through with the drop down. So you're going to hit start and it's going to start the system. I'm going to flip through these live now. So on the first tab, the System tab, if you click in passcode entry, the passcode, your passcode is 123. You're going to see this please wait, and you're going to think it's actually doing something. We're going to ask you to put that password in one more time. You're going to get these three little page flips. What this is actually getting into the torque transducer and allows you additional options for measure and visualize and some other things that you can do, saving to the transducer, the signal conditioning, and we'll go through these, but there's a couple different options you can do. So under the type description, this is pulling up right from your torque transducer. This is going to tell you your nominal value of your transducer, your shunt value, which is 50% and 10% of your values. The biggest thing here that you're going to notice is the rotor and stator versions. Basically what this is, on one of my other videos, I have a T12 and T12 HP series. This will tell if they're compatible to each other. And it also has the part number. So if you ever need to send it in for Cal or to have a question for it, it's always nice to have this part number because this tells it's a 1000 Newton meter, it's an FF1 series, no speed, things like that. So this is a very interesting screen that tells a lot of detail right off the bat. So the next one is general settings. You can go through here and put in your name of your project. If you want, you can change the language to English or German. Here is the password. It's 123 as default. Like I mentioned, you can change that to pretty much anything you want. And then it's going to ask you if you want to reset passcode. It's going to pop up with an error saying, hey, are you sure you want to do this? You're going to hit yes or no, and then it'll go from there. You can change that password as you please. Next option here is Fieldbus Interface. What this is, if you're running CAN or CAN in a series, this is going to tell you what is your PDO options and what's your baud rate for each one. So in each one, you could turn off PDO1, PDO2, depending on what you need. You want speed, you want power, rotor temperature, status. The status is basically similar to the light that's on the front of your transducer. If it's green, that means everything is good. The status, but this is a digital series, so if the status could be, running or not running, depending on alignment or stuff like that, you could throw a digital signal. We can talk about that in another video. The next option in the Fieldbus interface is CAN open or bus status. So since it is CAN open, all of the transducers do spit out all of your data, rotor temperature, torque, speed, all at once. But for some reason, if you do need to switch it back to pre-operational mode, so it shuts off the data stream, and then you can switch it back to operational, you can do that here. I do have another video that talks about switching it to operational. There's a couple different ways to do this. This is obviously the easiest, but there's another way through options through the SDO terminal. I have another video for that if you want to check it out on our website. The torque transducer that I have here is a Profibus and a CAN bus. I'm not going to go in the Profibus here, but you could set up all the Profibus address for each transducer here. For here, on this one, on this video, I'm just going to stick to CAN, and then I'll do another video with the Profibus setup as well. So I'm going to skip down to Parameterized Transducer tab. In here, this is where you can set up saying, okay, I want my torque to be in Newton meters. I want 3 zeros. This sign tab, the positive and negative, if you have your rotor sitting on your desk and you have the HBM logo on top, clockwise is positive, and then counterclockwise is going to be negative. So let's say if you set up your torque transducer and you're getting negative values, you're getting a negative, 100 Newton meters, you can go through and switch this to positive, and your notation of your actual values are going to change. In here we have a low pass filter 1 and low pass filter 2. Low pass filter 1 has a 0.05 hertz to 4 kilohertz filter you can set on that. Torque low pass 2 is a little bit different, 0.05 to 100 hertz. So that's your second signal that could be coming out of your torque transducer. You could do the same thing for speed. How many decimal points, positive, negative, and then your different filters. Angular rotation, same setup. Frequency output, I do want to spend some time on this one. Each of your transducers have a different range. This one right now is set up at 10 plus or minus 5 kilohertz for my 0. So the way that this is set up, I've got this is a 1000 Newton meters, so I'm going to put 1000 in. My first point is 0, and that corresponds to my 10 kilohertz. My second one is 1000, and that's 15 kilohertz. So depending on what you have selected on your transducer, if you're running a 10 or a 60, you'll need to go through and change these values. This does not automatically populate. All right, the next tab I'm going to cover is the signal conditioning. I'm going to select signal conditioning and then torque. Here is the shunt values that you can do, and then you can also zero your torque transducer. Well, to be able to see these values, you have to go to Measure and Visualize, down here on the very bottom one. Measured quantities. I'm going to pick torque low pass 1 and pull up a digital display. I'm going to slide this over. Again, this is just like any Microsoft project. You can just click on the files and drag and drop, depending on what you screen. If you want different things up, you can just click and move around. So I've got a temperature 1 up. I can slide and drag around. We'll cover that in a second. So while I have this up, I've got the digital display, measured quantities, torque low pass 1 digital display. In this range here, in the very bottom of this, you've got your torque transducer, what you're currently reading. Mine is on my desk, so I've got it, it's reading right at 0. The red, yellow, green chart on the bottom here, if your torque transducer is having issues, or if you're out of range, or if you're not getting enough voltage, or if your rotor's over temperature, there's multiple things here. So if you call into support, this is one of the first things that we pull up. We're going to pull up the description type. This is going to give you that part number that I showed you earlier. This is going to give you the part number and the range that everything is supposed to be in. And then if it's overheated or if there's an issue, this will kind of be a red, yellow, green chart of kind of the path that we go down to start to fix your issue and your concerns. So while this is up, I'm going to go back to my signal conditioning torque value, that's this box here. I'm going to enable my shunt value at 50%. This is going to switch right around 500. And this is based off of your cal sheet that you have when you send in your transducer back to Germany. So this value matches exactly what's on my cal sheet. So you can enable and disable that. And this is more just a check, making sure that your transducer is working. So when you get your transducer into your rig, you want to obviously check your zero to make sure it's still zero and not over torqued or over temped. But this is one way of sending electronic shunt to your transducer to check to make sure everything is okay with it. So I'm going to close this one out. I'm going to leave this this value up. This is my torque. You can go through and pull up like rotor temperature. Here in Detroit, welcome to Detroit, is 17.5 degrees C. It's been in my car on the way here. So, but this will actually give you the rotor temp inside the actual rotor itself. So keep in mind that the rotor itself is basically a hollow H. If you can kind of think of an H, the horizontal part is where the electronics are and your Wheatstone bridge strain gauges. So this will actually determine your temperature inside that. So the rotor temperature inside may be different than what's outside or maybe your ambient room temperature. So there's a couple different options here for speed. There's a digital display and an analog display, depending on what you're looking at. Obviously, is on my desk, so I'm not going to have a speed present. The next thing I want to talk about is Rotor Extrema. It's in the Measure and Visualize tab here. What this is this is a counter of what your actual torque transducer has witnessed. So we'll have a lot of calls and say, hey, this has never been over temped, has never been over torqued. Well, guess what? It's all recorded. So what this is, the min and max, max is in your positive direction. So again, your HBM torque transducer with your rotor facing up, clockwise is positive, that's your max value. Your min value is just your negative. So anytime that it's over 100%, it's going to record this. Keep in mind here that this time here and the time here on the bottom is just operating hours. Right now, my torque transducer is sitting on my desk. It's plugged in, it's spitting out a value. According to the torque transducer, this is actual log time. So it's not test time. We have a lot of people try to correlate this back to a test. But let's say if your torque transducer is on over the weekend or a holiday and your dyno is not running, so you're not actually running a physical test, but the torque transducer thinks that it's still running. So this is just a clock. It records temperature and it'll record torque. So for temperature, it's 1/10 C. That's how this is read. And again, this is just a time of kind of when this was. Be very careful with this. There's a Rotor Extrema reset on here. In support, we have a code. Obviously, you have as a customer have your 123 passcode as your default, or whichever one you set up from your customer site. But in support, we have one, and if this is reset saying, "Oh no, this has never been over torqued or over temped," our screen blinks red. If you send the torque transducer to Germany for cal or repair, their screen also blinks red, saying, "Hey, this has been reset." That saying that the customer knows that that we've had an issue with being over temped or over torqued. So this is a very good kind of a check for us, and it's a check for you as well. The next couple I want to show you under Measure and Visualize, there's the scope and the evaluation. This is just a check. This is not really, this is the check just making sure that your torque transducer is giving real values and not just straight zero, or it's not giving a 2 million number. If you get that 2 million number, basically what that means is your rotor is outside of your power window for your actual stator. So that's sending a signal saying, hey, there's something not aligned. The light on the front side of your torque transducer is going to be either yellow or red, depending on where that's at. But this is just a live check. And same thing with the evaluation. It's just more used as a live check. You can save the file, but this is not an actual test. So if you have any other transducers that are PTP stamped or time stamped, they may not follow, and it's not going to collect all the data. This graph here is based on the update rate and your video card on your actual computer, not the actual test data that's coming out of your transducer. So keep that in mind as you go through. Like I said, this is just a check. You can apply different filters on here just to see what your data is going to be kind of looking like. And then you can save it into your data hardware system, whether it be HBM or whatever you're running into. So the evaluation mode is just kind of a plot, and you can plot torque low pass 1, low pass 2. This is going to give you your min max. There's a graph that looks basically like the scope value. There's a couple of things you can do here, but like I said, this is more of a check. This is not actual test, your official test data. Make sure you go into a DAS hardware for that. So thank you for watching the video. If you do have any questions, please give us a call at 1-800-578-4260. Email us at support@usa.hbm.com. Check us out on our website for more videos, frequently asked questions, and our webinar series. Thanks again.